Hi students, good day to all. Today we're going to discuss electrical simulation of fluid sim circuit such as the following sequence A plus B plus B minus A minus. Okay, so here as per the time we have less time, so I'm not built a circuit, so I will explain the built circuit how it's work. Okay, so compare with previously built manually controlled fluidic circuit, this circuit has required very less component and no confusion in circuit connections. So cylinder which is actuated by directly actuated by the solenoid operated 4 by 2 DCV or else 5 by 2 DCV. Okay, so here this is the indirect electrical control relay ladder diagram. Okay, so whenever a relay 1 activate, it going to execute the sequence of A plus B plus. Whenever the relay 2 going to activate, it going to activate B minus A minus. While the relay 2 energize, we need to de-energize the relay 1. So therefore I here use a make switch. So here I use a brake switch. Here I use the brake switch to de-energize the relay 1. Okay, so here I do the latching concept here. Okay, here I do the latching concept here to keep on energizing the relay 1 after release the push button. Okay, so when you push this button, relay 1 will be energized. When relay 1 will be energized, it will be energized the solenoid 1. When solenoid 1 energized, it will be actuate the A cylinder. When A cylinder externed, A plus will be happy. A plus limit switch get closed. This will be energize the solenoid 3 to energize the B cylinder, and when B cylinder externed, it will be closed the limit switch B plus. Therefore relay 2 will be energized. Whenever the relay 2 will be energized, what will be happen? So the relay 2 will be energized after the B cylinder is turned, and it will be given in latching. So here we put a brake switch, A minus brake switch. So that is A minus brake switch. It is a normally closed switch. Brake switch means normally closed switch. It is held to open. Normally closed, held to open switch. Normally closed, held open switch. Okay. It is normally closed held open switch. Okay, and this is normally open held closed switch here. Okay, so here it is normally open held closed, here normally closed held open. So whenever for de-energizing the relay 2 to continue the sequence, as per to continue the sequence A plus B plus B minus A minus, this should be happen continuously. So we need to de-energize the relay whenever the A cylinder whenever the A cylinder retract. So whenever the A cylinder retract, it getting close, it getting open. Okay, so now you see, can see the simulation. So push this button to energize the relay 1. The solenoid will be energized. I just push this button to supply the fluidic energy to the cylinders. A plus B minus A minus will be happen. Here you can see what will be happen. So whenever when you push the button, relay 1 will be energized. Relay 1 will be energized. It will be extend the A cylinder and then B cylinder, and then B cylinder retract, and then A cylinder retract. So it gets open here. You can see after retracting, this will be open to break this connection. To break this connection. So here also I am using the uh, I'm using 4 relays to perform the A plus B plus A minus B minus. Okay. plus B minus A minus. So here I am using 4 relays. So A plus, B plus, B minus, A minus. Okay. So this is the indirect electrical ladder diagram for the sequence of A plus, B plus, B minus, A minus. Okay. Here what I do is I use individual relay to operate individual solenoids such as Y1, Y2, Y3, Y4. Okay. So relay 1 going to use to extend the A cylinder, relay 2 going to extend the B cylinder, relay 2 used to going to retract the B cylinder, relay 4 used to retract the A cylinder. Okay. So here I what I do is I make uh, whenever the relay I make relay 1 energize will use to energize the relay 2. Relay 2 energize will use to energize the relay 3. Relay 3 energize which is used to energize the relay 4. But I want to break the relay 2 whenever the B cylinder need to be retract, because relay 2 will be extend the A cylinder. I want to break the relay 2, okay, which is energize the solenoid 2. So what I do is whenever the relay 3 is energized, here I put normally closed switch. So whenever relay 3 energized, this will be closed, this will be open. So solenoid 2 will be de-energized. Okay, when you energize the solenoid 3, the solenoid 2 need to be de-energized. Then only I can retract the B cylinder. So what I do is I put normally closed switch here, normally open switch here. Okay, so this is a single pole double throw switch. Okay, so that is the way I energize the relay 3 and de-energize the relay 2. Okay, so same thing I do for relay 4. So whenever the relay 4, whenever same thing I do for solenoid 4, whenever the solenoid 4 energized, the solenoid 1 need to be de-energized. Solenoid 4 will be energized by relay 4. I want to de-energize the solenoid 1. So here I put normally closed switch, here I put normally open switch. This way I can do the sequence for the A plus B plus B minus A minus using electrical control ladder diagram. So you can see the sequence A plus B plus B minus A minus. Here I use relay 4, normally closed switch here, normally open switch here. Okay, I want to give the break for individual drilling operation. So after drilling the workpiece, I need to retrieve the workpiece from the workstation. So therefore every time I need to press the button to initiate the drilling operation. If I remove this relay 4 normally closed switch, the sequence will be happen continuously. You can see A plus, B plus, B minus, A minus, and then it will be happen continuously. Sorry, here there is a problem because of relay 3 and relay 4 will be in energized condition. Okay, so here wall block will be happen. So I want to break this thing by putting relay 4 here. Sorry. So when you go for 3 cylinder sequence, so you need to use this same logic, you can construct the three cylinder sequence, which I do earlierly. Using the same concept I do here. So one should be A plus, B plus, B minus, A minus, C plus, C minus, and A plus, B plus. The sequence will be continuous as usual. A plus, B plus, B minus, A minus, C plus, C minus. Here I am using 6 relays for actuating 6 solenoid. Okay, the same concept I used here. So the C cylinder extension and retraction will be used to remove the workpiece from the workstation after drilling the job. Okay, so that should be the function. Here I put uh, only close the push button. A plus, B plus, B minus, A minus, C plus, and C minus. Okay, the C cylinder will use to remove the workpiece from the workstation. The sequences as usual happen. So here, when I want to energize the relay 5, I need to ensure that C cylinder should be in retract condition. In the meantime, B cylinder should be in retract condition. Okay, B cylinder, that is the drill bit should be retract, then only the C cylinder will extend to remove the workpiece from the workstation. Okay, so then only the relay 5 will be energized, and that relay 5 is used to energize the solenoid 5. For energizing the solenoid 5, we need to ensure relay 3 and relay 4 should be energized. That means the A cylinder and B cylinder should be in retract condition. Okay, so then only the relay 5 need to be energized. Okay, sorry, then only the solenoid 5 need to be energized. So once the solenoid 5 will be energized, the C cylinder will be extend. So once the C cylinder extend, what will be happen? The S6 limit switch get closed and it energizes the relay 6, and the relay 6 will be energized the solenoid 6, the C cylinder will be retract. Okay, so I will after some time period I will give the clear explanation how to build a circuit using relay diagram. I will post this I will post this I will post this fluid sim file to you, later I will give you the clear screencast video. You need to do multiple times. You get errors for individually activating the sequence. Okay, so when you get errors, you have the idea how to rectify the errors. Okay, so you will work for more sequence like what we discuss in manual method. That method you can do with electrical control, you can get the idea how to do the electrical control ladder diagram for different sequences. Okay, so when you work with that, you can get the idea how to do the electrical control ladder diagram for different sequences. Thank you.